All right, this is part A of the potential energy of a spring experiment, experiment 13. We're going to do what we need to do for data table 1. And this is what you're going to see when you first come to the phet.colorado.edu link that I send you, the Mass Spring Lab. And you just click on the play button here. It's not really going to play a video or anything. It's going to bring you to the experiment. And you've got 4 options: intro, vectors, energy, and lab. We want to choose the energy. That's the one we're doing. Now, there's some housekeeping here. The mass, you can adjust it with the slider. You can see that the little mass here in the corner grows and diminishes with the changing of the slider. It might be better to use the little slider for what we're going to do. Let's make it all the way to the bottom. You can change the spring constant. There's no arrows. You just use a slider. Set it somewhere in the middle. Somewhere in the middle. And as I want you to do a screen capture of your settings so I can know what it's set at when you run your experiment. Now, other housekeeping things that we need to do. We want the displacement on, we want the mass equilibrium point on, and we want this movable line. Of course, we want the gravity of the Earth, and we're gonna want lots of damping, and you'll see why. Sorry about the dogs. That's just part of living in this house. And we're gonna grab a ruler here. You'll see there's a ruler. We're gonna grab it, and we're gonna put it right there at the bottom. Let's see, right around there. Okay. Now, so I've got I think I've got everything set. The displacement, the mass, the movable line, gravity is on Earth, and now I hang this on here. Oh, and look, see, it bounces, it bounces, it bounces. You want to you can slow that down if you put it with lots of damping. We'll do that again. We'll hang the mass there, and you'll see how quickly it comes to a equilibrium point. Now, it's going to be difficult to read. Let's just read. Okay, where is this arrow pointing? Well, is it 10? It looks like a little more than 10. Well, I'll tell you what. Let's set it somewhere that we can see. I'm setting it there at 15. There's 15, and let's increase the mass until we get to that 15. So, let's see. And I'm looking at that green arrow. When that green arrow touches, okay, there's like 83 grams at 15 centimeters down. Okay, now let's move this to the 20, and let's increase the mass. Is that about right? Yeah, that's the arrow pointing at 20, so that's 117 grams at 20, and you can just keep going. You can set this for 25, and you increase it until the arrow reaches it as best you can, and then you just you record the data. You just keep doing that until you exhaust the tables. You have 8 positions available to you, so you can just play with it, and you just fill out your data table. You plot the data. Now I'm going to want you to convert all those grams to kilograms and get a newtons. You want, because spring constant needs to be in newtons per meter. So you do that, you come up with a K, and then we'll use the K in the next section. And so that's it for doing the spring constant, the part A of your part A of the experiment.